All right, guys, so we are going to keep diving into acids and bases. We talked about the Arrhenius and Bronsted-Lowry acids and bases. One thing that we deal with acids and bases is where solutions can be acidic or basic, even if they don't follow one of our basic definitions. So we're also going to look at what happens whenever we have a salt. So remember, salt is any ionic compound that can split into ions. So with salts, they can be considered acidic, basic, or neutral. So we're going to delve further into that. A quick recap. So explaining in words how to find the pH of the following. So remember, a strong acid, the hydrogen ion concentration is equal to the concentration of the acid. So we can simply plug that into the pH formula. Weak acids, though, remember you need an ice table to figure out that hydrogen ion concentration to find pH. Strong bases, the concentration of the base will equal the concentration of OH. From there, we can find POH, which we can use to find pH. Weak bases, however, just like weak acids, we need an ice table, and that ice table will give us the hydroxide ion concentration, which we can use to find POH and then change into pH. So remember, anything that is weak, you have to have an ice table for. So remember, what makes a solution acidic is that when it is put in solution, it produces those hydrogen ions that are shown in red here. So anything that can produce hydrogen ions can be considered acidic. And flipping over to what makes a solution basic, any base can produce hydroxide ions when in solution. Now, those hydroxide ions might come from water, but they can still produce hydroxide ions in solution. So that is going to lead us further in. So remember, an acidic solution, we said, is going to produce some form of hydrogen ion in solution. We've looked at typical things that we consider to be acidic, like hydrogen bromide. Whenever it is placed in water, it can split into the hydronium ions, which, remember, pretty much same as the hydrogen ions. They're just not floating around by themselves, and the bromide ions. So yet again, it produces some form of that hydrogen ion in solution. That is an example of one of our stronger bases. Whereas we have something like nitrous acid, which is a weak base. Yet again, whenever it's put in water, we get that it can produce the hydronium ion and the nitrite ion, but it is at equilibrium, but still it produces that hydronium ion. Here's where salts come in. Some cations, so those positively charged ions, can act as acidic. So some of those ions, when in solution, can produce hydrogen ions. So let's look at ammonium, which is NH4. Whenever this is put in water, it has a hydrogen to release, so it will make ammonia and the hydronium ion. So it does produce that hydronium ion in solution. So it can act as an acidic cation. And we're going to look at these a little bit more and do some examples, but understand that cations, if they can produce that hydrogen ion or hydronium ion, they can behave as acidic. Right. And we said with basic solutions, remember these are somehow going to produce hydroxide ions in solution. So we have our strong bases like potassium hydroxide that will split into the potassium ion and hydroxide ions in solution. We also have our weak bases, something like ammonia, where when it reacts with water, it's at that equilibrium system and it accepts that hydrogen to make ammonium, and then we have hydroxide left over from water. Those are typical ones that we've used before. But whenever we bring salts into it, some of the anions can act as basic. So the anions, when in water, can produce those hydroxide ions. So fluoride is one of those. So fluoride, whenever it is put in water, since it has a negative charge, it can attract that positive hydrogen, making HF, and leave behind hydroxide. So yet again, it somehow produces that hydroxide. The hydroxide tends to come from water, but it acts as a base because it can accept that hydrogen from the water. All right, I'm picking up where we left off yesterday. Like we said, those conjugate acid base pairs, the stronger the Bronsted acid, the weaker its conjugate base will be. Sorry. And the stronger Bronsted base, the weaker its conjugate acid will be. And this we use by comparing the Ka and Kb of these individual substances. And with the salts, so the anion that is the conjugate base of a weak acid is going to be considered a weak base. So weak acids conjugate base is going to be a weak base. If the anion of a strong acid, its conjugate base is going to be neutral. And this, I'll show you how this matters in a moment. So anions that are from a weak acid are considered to be weak bases, but if they're from a strong acid, they're considered to be neutral. On the flip side, looking at the cations, a cation that is the conjugate acid of a weak base is considered to be a weak acid. However, if the cation is from a strong base, it is considered to be neutral. So with salts, if those ions are part of a weak acid or weak base, they can act as a weak acid or weak base on their own when in a salt. So let's look at this further. Looking at anions first. It's like we said, anions like fluoride. This is going to be the anion from the acid hydrofluoric acid, which hydrofluoric acid is a weak acid. It is not on our memorization list. So looking at how it behaves, we can take this fluoride, add it to water, and it will produce the hydrofluoric acid, which is weak, and hydroxide. So since it does produce hydroxide, that's why that anion can act as a base. Looking at another one, here we have the oxalate ion, which can be derived from oxalic acid, which you might see written either way with 2 hydrogens or the hydrogen oxalate ion. Same kind of thing here. We can take the oxalate, put it in water. Oxalic acid is not one of our strong acids, so we know it has to be weak. This can produce that hydrogen oxalate ion and leave behind hydroxide. So this can still act as a base, producing that hydroxide. However, if we take something like chlorine, or the chloride ion coming from hydrochloric acid, which is a strong acid, if we tried to put this in water, it would produce hydrochloric acid and hydroxide. However, this is a strong acid, meaning that it will completely ionize back into the chloride and water. So this is not basic because it is derived from one of our strong acids. So that chloride would be neutral, whereas the fluoride and the oxalate ion would be basic. All right, guys, I'm gonna have to stop here and come back for part 2, where we'll look at cations and then look at the salt hydrolysis. So looking at if a salt itself can be acidic or basic.